In this video, we're going to be looking at the surface area of a solid revolution. Okay, so there's two things that can happen. We can take a function, and I can take this function and revolve it around the x-axis. All right, and what I want to do is I want to find the surface area of that solid, or I can take a function with respect to y, and I can revolve it around the y-axis, and I want the surface area of that solid revolution. Okay, so what's the objective of this video? State the correct formula to be used in finding the areas of surfaces of revolutions and find the surface area of a solid revolution. Okay, so we need to visualize what we're actually doing here. Now, what you need to understand is I want the surface area. In other words, I want this little part here that's getting revolved about the x-axis. So I want this surface area. I don't want the circles, I want the surface area, the sides. So what would happen? What do I need? Well, I'm gonna need this length, and this length has a very important name. It's called the arc length. And arc length is another video that we studied already in this class, right? The arc length is found. And what else do I need? Well, I'm going to take this arc length and I'm going to revolve it around the x-axis. So I'm going to need this right here because I really need the circumference. And what's the circumference? The circumference is 2 pi r. But right here, my r is going to be determined by the what? By the function. So I'm really going to need f of x. Okay? So I'm actually going to do the integral 2 pi r, but we said r is f of x, and then I'm going to take that and I'm going to multiply it times my arc length. Now what's my arc length? The arc length is going to be 1 plus the derivative squared. So here's the formula. The formula is going to be 2 pi f of x times the square root of 1 plus the derivative squared dx, and it's going to be from wherever you want that arc length to be. So if I want it from 1 to 2, then my bounds will be from 1 to 2. Okay, now let's visualize the one that is about the y-axis. What I have is I have this curve right here, which is a function of y, f of y, and I'm going to revolve it around the y-axis. So I'm going to go around like this around the y-axis. So what's the surface area going to be? The surface area is going to be my circumference, right, times my arc length. So it's going to be the integral from a, well, we'll call it from c to d because we're using y here. I'm going to say the integral from c to d, and this right here, he's my radius. So it's going to be 2 pi r. But r has to be a function. It's going to be an x coordinate. Okay, so it's really going to be f of y. F of y. Now, if you notice, that is not f of x. F of x is really y. F of y is really x times the square root of what? Times the derivative, right? The arc length. 1 plus the derivative squared. Okay, and I can put it in terms of x as long as I convert this guy to x. So let's look at the formula. Okay, now here it's going to be a length of x because it's unknown, dy, or you can say g of y dy. Okay, and I think I made a mistake on that one. Okay, so here we go. Let's go ahead and just set up the integrals. Find me the integral. Set up the surface area for the solid revolution when you take x squared and revolve it about the x-axis. Okay, so we're going to say it's going to be the integral from 0 to 2 pi times y here, times y, Now the y, remember that we were revolving it about the x-axis. So my y at different locations is going to be determined by my function. So I'm just going to type in my function here, x squared square root of 1 plus the derivative of my function. And the derivative of the function is going to be 2x, but then I want to square it, and it's going to be with respect to x. And that's it. That's the setup for the surface area about the x-axis. So let's look at the more complicated one, okay? Now we have one that's with respect to, well, we're going to go about the y-axis, okay? Now, the great part is I'm giving you a function x equals, okay? It's not a function, I'm giving you the relationship that x is equal to y plus 2 square root of y. So this is not the hard part, okay? So I'm going to say my bounds are very simple. It's also going to be with respect to y. What I needed to say about my formula here is I did make a mistake, okay? My mistake is I put dy dx, and this should be dx dy. Dx dy, okay? That's my mistake. Alright, so if I was to set this up, I would say the integral from 1 to 2, and I want to put in here 2 pi x. Now remember, we're actually doing it with the opposite letter, because when I go around the y-axis, I'm traveling, my radius is really going to be an x value. All right, so 2 pi x, the square root of 1 plus dx dy squared dy. So all we have to do now is make sure that everything's in terms of y. But sir, this is not in terms of y. Don't worry, we'll convert it right now. 1 over 2 pi, but what is x? X is going to equal to y plus 2 square root of y. And now we have to worry about this one here. So I'm going to say 1 plus dx dy. Now here's where I lose some students, all right? This is not dy dx. So what I have to do is I have to take the derivative of it. I'm going to take the derivative of this function. So x is going to equal to, oops, I already have it there. So I'm going to undo. I'm going to take the derivative with respect to y. That's all I'm going to do. So the derivative of x with respect to y is dx dy is going to equal to 1 plus 2 over 2 square root of y. Let's just reduce here. So I'm going to be left with 1 plus 1 over square root of y. So this right there is going to be my derivative. So I'm going to put in here 1 plus 1 over square root of y squared dy. And basically, I'm testing you whether you can set it up or not. You know, to solve something like that, I don't expect you to solve it, because it can take the whole period to do one problem. So you can just plug it in the calculator. Okay. All right. So just make sure that you understand the two formulas here. If I want about the y-axis, you're going to put an x here and make sure that's dx dy, and over here is going to be dy. And if you're going about the x-axis, since I see an x here, I want to put a y here, and it's going to be dy dx squared.